Solving radical equations. So radical equations are equations that have some kind of a root in them. So a square root, a cube root, a fourth root, any of those. So to solve these, we're going to first isolate the radical on one side of the equation. So let's look at example 1 and do these steps one by one. So for example 1, it says solve the 2 times the square root of x plus 1 equals 4. So to isolate this radical, I'm going to have to divide both sides by 2. So you end up having square root of x plus 1 equals 4 divided by 2 makes 2. Step 2 says raise each side of the equation to the same exponent as the index of the radical. So if you have a square root, the inverse of a square root is a square. So we're going to take both sides and square them. So on the left, the square and the square root are inverses, so they undo each other. So all that's left is x plus 1. Then on the right-hand side, 2 squared is equal to 4. Then step 3 is solve the resulting equation just like normal. So in this case, to get x alone, we would have to subtract 1 from both sides. And x would equal to 3. Last but not least, we still have to check our answer in the original equation to make sure we don't have any of those extraneous solutions. So extraneous solutions are those when you substitute them back in, they either give a false statement or they do something that's not mathematically possible. So we are going to have to do a check on all of these radical equations, just like the rational equations. So when you plug in the x equals 3, we're going to make sure this is actually true. So 2 times the square root of 3 plus 1 equals 4. 2 times the square root of 4. Well, square root of 4 is a 2. And 2 times 2 does in fact equal 4. So since this is true, this is not an extraneous solution. This is your final answer. Let's try another one. What is the solution to the cube root of 2x minus 9 minus 1 equals 2? So step 1, isolate the radical. So in this case, it's a cube root. So I'm going to have to add 1 to both sides to get the cube root by itself. 2 plus 1 makes 3. Then undo the cube root. So the inverse of a cube root is a third power. So the cube and the cube root are inverses, so they undo each other. So all that's left is 2x minus 9. And then 3 to the third makes 27. Now solve this like a regular equation. Add 9 to both sides. 2x equals 36. Divide both sides by 2. X is equal to 18. And again, we need to check this to make sure there isn't an extraneous solution as well. So we're going to substitute this 18 back into the original equation to make sure that it works. So the cube root of, so this is our check. The cube root of 2 times 18 minus 9 minus 1 equals 2. Cube root of 36 minus 9 minus 1 equals 2. Well, 36 minus 9 makes 27. The cube root of 27 is equal to 3. 3 minus 1 makes 2. So this is a true statement. So x equals 18 is your solution. Now I got x's on both sides this time. So solve x plus 1 equals the square root of 7x plus 15. So the radical is the only thing we need to worry about being isolated right now. And it is. On this side of the equal sign, there's nothing else besides this square root. So the inverse of a square root is squaring both sides. So on the right-hand side, when you square this, all you have left is what's underneath the radical. But when you square x plus 1, that's really saying x plus 1 times itself. So I'm going to have to use that double distribution to actually multiply this out. X times x makes x squared. X times 1 makes x. 1 times x makes x. And 1 times 1 makes 1. Combine like terms. X squared plus 2x plus 1 equals 7x plus 15. So since I have this x squared, I'm going to have to factor this in order to solve it. But first, I need to get this in standard form, so I need to move everything over to one side. I'm going to move this 7x, and I'm going to move the positive 15. So you end up with x squared minus 5x minus 14 equals 0. So we're going to have to factor this in order to solve. So there's 3 terms, so I need to use my AC method. A is a 1, B is a -5, C is -14. So I need two numbers that will multiply to be -14, but also add up to be -5. The two numbers that are going to do that are -7 times 2. So when you multiply -7 and 2, you get -14. But if you add them, you end up with a -5. So since A is a 1, we can use our shortcut factoring for this example. So we can go ahead and set up our factors. So we're going to have x minus 7 in one of the factors and x plus 2 in the other factor equal to 0. So to solve this, split this into two smaller equations and solve them individually. Add 7 to both sides, you get x equals 7. Subtract 2 from both sides, x equals -2. Now, these could both be solutions, but I have to make sure I check them in my original equation to make sure they aren't extraneous. So that's the last step, is we're going to have to check both of these to make sure that they do in fact give true statements. So we're going to check x equals 7 first. So we're going to have 7 plus 1 equals the square root of 7 times 7 plus 15. 7 plus 1 makes 8. 7 times 7 makes 49 plus 15. 8 equals the square root of 64. And the square root of 64 is in fact an 8. So x equals 7 is a solution to this radical equation. Next one we're going to have to check is when x is equal to -2. So we're going to substitute this in as well. So -2 plus 1 equals the square root of 7 times -2 plus 15. -2 plus 1 makes -1. 7 times -2 makes -14 plus 15. -1 equals the square root of 1. Well, the square root of 1 is a 1. So since that's not true, this is not a good solution. So the only solution you have for this example is x equals 7. And let's try one more. What if you have a radical on both sides of your equal sign? Well, we're going to have to square both sides still. So since both of them are square roots, we're going to have to do a square on both sides to get rid of the square roots. So for the left side, we are going to have to remember that I have square root of x plus 2 plus 1 times itself, because there's more than one term here. And then on the right side, the squares and the square roots will cancel out, and all you're left with is 3 minus x. So we have the square root of x plus 2 times the square root of x plus 2. So since you did the same square root times itself, you're going to be left with what's underneath. The square root part cancels out. Then you have the square root of x plus 2 times a 1. So you're going to have plus square root x plus 2. Then you're going to have 1 times another square root of x plus 2. So square root x plus 2. And then 1 times 1 makes 1 equals 3 minus x. Combine like terms. So you're going to have x, 2, and 1 are like terms, so that makes a 3. X square root of x plus 2, square root of x plus 2 are like terms, so you're going to have 2 square root of x plus 2 equals 3 minus x. Now, we weren't able to completely get rid of my radical because I still have a square root right here. So what I'm going to do is I'm going to move everything away from that square root. So isolate the square root. So I'm going to subtract x, and I'm going to subtract 3. So you're going to end up with 2 square root x plus 2 equals 3 minus 3 makes 0, and then you have a -2x. Now we need to get rid of the 2 in front of the radical, so I'm going to divide both sides by 2. So I have square root of x plus 2 equals -x. Now that the radical is isolated, we're going to square both sides again to get rid of this last square root. So you end up with x plus 2 equals, and the -x squared is just a positive x squared. So again, since I'm left with an x squared, you're going to have to factor this in order to solve. But first, I'm going to have to move everything over. Now, I need the squared to be positive, so I'm going to actually move the x and the 2 in order to keep my x squared positive. So 0 equals x squared minus x minus 2. So I need two numbers that multiply to a -2 but add up to -1. And the two numbers that are going to do that for me is -2 times a +1. And again, this x squared has a 1, so we can use our shortcut. So we're going to have x minus 2 for one of the factors and x plus 1 as the other factor. Take each factor and set it equal to 0 and solve them individually. So the first one is x equals negative 2, and the second solution is x equals negative 1. Just like our previous example, we're going to need to make sure we check both of these solutions in our original equation. So we're going to check. So we're going to have to check this negative 2 first. So we have negative 2 plus 2 square root plus 1 should equal the square root of 3 minus a negative 2. So negative 2 plus 2 makes 0. Then we have 3 minus a negative 2, so that's really plus 2. And 3 plus 2 makes 5. Well, the square root of 0 is 0, so we have 1 equals the square root of 5. Well, that's not a true statement, so that means x equals negative 2 is not a solution. So now we check the other solution. So we're going to have the square root of negative 1 plus 2 plus 1 equals the square root of 3 minus negative 1. So on the left, negative 1 plus 2 makes a 1. Then we have, again, negative and a negative make an add. So 3 plus 1 is really 4. So the square root of 1 is 1. The square root of 4 is a 2. And 1 plus 1 makes 2. And 2 does equal 2. So x equals negative 1 is our solution. Our final examples are, what do you do when you have exponents that are fractions? How do you solve something like this? Well, the same first step applies. Isolate whatever has that exponent attached to it. So I need to move this positive 2 to the other side. So I have 2x to the 3/4 power equals an 8. Now, to get rid of a 3/4 power, you need to use the reciprocal of the exponent. So I basically need to make the exponent a 1. So if I have a 3/4 and I raise it to a 4/3 power, that's going to multiply to a 1, which is how you undo it. So we're going to have to take both sides and raise it to a 4/3 power. So this 8 needs to be raised to the 4/3. So this 3/4 and this 4/3 end up giving you 2x to the first power. Because if you have power to a power, you're going to multiply, which is this on the side. 3/4 times 4/3 is equal to a 1. Then on the right hand side, I have 8 to the 4/3. On the left, 2x to the first is just 2x. Now, 8 to the 4/3 doesn't help me a whole lot. But I do know that I can change 8 to the 4/3 into its radical form. So it's going to be an index of a 3, 8 to the 4th. So to simplify this cube root of 8 to the 4th, I'm going to use this kind of like I would variables. 8 to the 4th means there's 8 times 8 times 8 times 8. So how many groups of 3 8s can I make out of this? Well, I can pair up these 3 8s, and this one's going to have to stay inside. So 1 8 is going to go to the outside of my cube root. Then you're going to have 1 8 left over that you couldn't pair up. Now, the cube root of 8 is actually a perfect cube because we can break this 8 into 4 times 2, and I can break this 4 into 2 times 2. And again, here's another group of 3 numbers. So we have the 8 from the first simplification times the 2. Then we would have a cube root, but there's nothing left without a pair. So 8 times 2 makes 16. So what your equation turns into is 2x equals 16 by simplifying the cube root of 8 to the 4th. Then solve this equation just like normal. Divide by 2 on both sides. So your x is equal to 8. Let's do one more. X plus 30 to the 1/2 equals x. So the power is already isolated. So to get rid of a 1/2, you're going to want to multiply again or raise it to the reciprocal. So the reciprocal of 1/2 is a 2. 2 over 1 makes 2. Raise the right side to a square. So multiply your powers together according to our exponent rules. 1/2 times 2 makes a 1. And then this will just be x squared. Well, x plus 30 to the first is just x plus 30 equals x squared. Again, we're going to have to factor this because I have my x squared. So I need to move this to the right because I need to keep my squared positive. So 0 equals x squared minus x minus 30. So this is another AC method, so I need numbers that are going to multiply to negative 30 but add up to a negative 1. Well, that's going to be negative 6 times a positive 5. Since a is equal to a 1, we can use our shortcut. X minus 6 times x plus 5. Set each factor equal to 0. And then solve them individually. So we get x equals 6 and x equals negative 5. Now, because I got two x values, I need to make sure that they're both solutions. So we're going to have to check both of these, make sure they're good. So we end up with 6 plus 30 to the 1/2 equals 6. So 6 plus 30 is 36 to the 1/2 equals 6. Change this into its radical form. So this is really the square root of 36 equals 6. And the square root of 36 is in fact a 6. So yes, x equals 6 is a solution. So now we need to check negative 5. Negative 5 plus 30 to the 1/2 equals negative 5. Negative 5 plus 30 makes 25 to the 1/2 equals negative 5. Anything to the 1/2 really means the square root of 25 equals negative 5. Well, the square root of 25 is a positive 5, and that's not equal to negative 5. So this is not a solution. The only solution you have is x equals 6.